Hello, hello everyone. Welcome to a new virtual tour of the European Southern Observatory, or simply ESO. It's acronym. My name is Farid Char, and with the producer Felipe Zurita, we are going to be your guides during this trip to ESO Paranal Observatory. So just a little bit about me. I have more than 15 years of experience in astronomy outreach and education. I am one of the guides of the observatory since 2010. I am also part of the Astronomy Center of the University of Antofagasta. And regarding my personal hobbies, well, I am interested in astronomy observations, of course, and astrophotography. But as I told you before, I am not alone. I am with the producer, Felipe. How are you, Felipe?
Hi, Farid. Hi, everyone. I'm fine. My name is Felipe Zurita. I have a degree in astronomy in University of La Serena, and I love sharing science and astronomy with people. I will be the producer for this online tour, so you can leave your questions, your greetings whenever you want to leave in a chat box. And we have in this moment a greeting for Turkey, Algeria, and hello 2025 ESO. Hello everyone. Remember, you can leave your questions everyone you want about astronomy. Farid and I know know about astronomy or for space, whatever you want to know. So thank you for thank you for see us. Um, Come on, Farid.
Okay, thank you very much, Felipe. So yeah, ISO wants to be with you during this virtual visits and bring astronomy directly to your home or wherever you are. So please remember, you can send your questions or comments during all this streaming.
Mhm.
So to do that, please use the comment section in the on Facebook or YouTube, and later we will have some specific time to answer to your questions. Okay. Okay. So we are going to start with this virtual experience, and the first thing I am going to do is to help you to understand the place of our visit. So we will visit. We will begin this tour with some information about the European Southern Observatory, or ESO. So in this case, ESO is composed of 16 member states. The headquarters of ESO are located in Germany. Also, Australia has joined ESO as a strategic partner, and Chile is the host state and is the home of all ESO observatories. So from the 1960s, and with those objectives in mind, ESO has chosen one of the best places on the planet for astronomical observations, the Atacama Desert in Chile. So during this period, Chile started several site explorations in order to attract international observatories, such as ESO, to our country. As a result, Chile offered its territory, and ESO did choose the more suitable areas. So in this case, the mission of ESO is to design, build, and operate astronomical observatories. Why? To enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy field. Yeah, so right now, you will see another picture with the three observation sites of ESO in Chile. So here we have, for example, the Chagnator Plateau, and this is the site of the ALMA and APEX radio telescopes. So ESO is part of these places for radio astronomy alongside other international partners. Additionally, south of the Atacama Desert at 2,400 meters above the sea level, we have La Silla Observatory in the Coquimbo region in Chile. So this ESO observatory is the home of several telescopes, such as the NTT or the 3.6-meter ESO telescope. And this one specifically is using the HARPS instrument, and this is an exoplanet hunter. And finally, we have the place of our visit, the Paranal Observatory. This ESO observatory is the home of the Very Large Telescope, or VLT. This is the most advanced visible light telescope on Earth. In the next few years, we will also have the Extremely Large Telescope, or ELT, and this will be the biggest visible light telescope on Earth. Also, near there, the CTA will be an array of telescopes, in this case investigating the gamma rays. Okay, now we have a better picture. So from now, we are going to travel to Paranal Observatory. So right now, in this virtual animation, we are flying over the Atacama Desert in the north of Chile, about 1,600 kilometers north of the capital Santiago, specifically about 130 kilometers south of Antofagasta, the regional capital, and about 90 kilometers north of Taltal, the closest city. So now we are going toward the mountain top of Cerro Paranal, located at 2,600 meters above sea level. This mountain belongs to the coastal range, and despite its altitude, it is located at just 12 kilometers from the coast. And where's the ocean? Well, the Pacific Ocean is located below of this cloud cover. So why those clouds if right here the sky is so clear, dry, and lonely? Well, this is because of the influence of the Humboldt current. This is a cold current or stream near the coast of Chile and Peru, cooling the atmosphere and causing a phenomenon called thermal inversion at about 1,000 meters above sea level, keeping below the cold, humid, and basically bad air for astronomy. And about the layer, instead, we have the hot, dry, and less dense air. So this is something like the good air for astronomy. The clouds are blocked by the coastal range, and near Paranal, the mountains are high enough, surpassing the 2,000 meters above sea level. Okay, so what other natural barriers we have around this area? Well, about 200 kilometers to the east, we have the Andes Mountains, with very high mountains, more than 6,000 meters above sea level. So this is basically another natural barrier blocking the clouds coming from Argentina and Bolivia. So the main result is this landscape, a place with an average of more than 300 clear nights per year, with a very clear and transparent atmosphere, making it ideal for observing the night sky. Also, here we are far away from artificial light sources because of human activity. I mean, light pollution. So, this is one of the best places on Earth for astronomical observations. In this animation here, you are looking at an even closer look to Paranal. So, as you can see, this is not an ordinary mountain. And now we can see the different telescopes and structures in the mountain. We are at the summit of Cerro Paranal. So, do you know what Paranal means? Well, in the Quechua language, Paranal means whirlwind, possibly because of some whirlwinds forming in the desert. However, as I told you already, the atmosphere here is extremely quiet. This observatory is a true oasis. So you will see how in one of the driest deserts we have a lot of life, and of course we have a lot of science. Okay. Okay. So right now we are going to visit um, the summit of Cerro Paranal, and here we are. Okay. So in front of us we have the Very Large Telescope, or VLT. It's acronym. If you see the amount of buildings, I mean, four giant domes and other for small and rounded ones, and I am talking about those ones, um, it's clear that the very large telescope is not only one, but a very special array of telescopes. So all this facility is the most advanced optical observatory on Earth. So let's take a closer look. Um, Here you can find the four unit telescopes. Okay, so each one um, with a primary mirror of 8.2 meters of diameter. So basically, the big ones, the giant ones in your screen. Um, and the other small ones, I mean, these ones here, this one, this one, and this one are the auxiliary telescopes, or ATs, each one with a primary mirror of 1.8 meters in diameter. Now, each UT, I mean the big ones, they have a name in Mapudungun language. This is the language of the Mapuche culture. They are natives from central and south of Chile. So I will tell you the names. The first one here is Antu, and Antu means sun in Mapuche. The second one is Cuyen, and this one means moon. Okay, this one here is Melipal. This one stands for 4 stars, but this is related to the Southern Cross constellation. And this one is Jepun. And Jepun is a concept basically talking about the planet Venus. Okay, so this is basically the meaning of the telescope names. Now, as I told you already, we have other telescopes, the small ones here, the auxiliary telescopes, right? So the important thing about the auxiliary telescopes is that they are mobile. We can move those telescopes using a rail system, this one. So basically we can change the position, the station of each auxiliary telescope. We have 30 different positions, so we can change the configuration of the auxiliary telescopes in this platform. They were specifically designed to work all together as a single big telescope with a variable diameter. Um, and this system is able to reach up to 200 meters, as you will see in a few moments in animation. We have an animation here. Okay, this one. Yeah, thank you. So the technique to combine light from several telescopes is called interferometry. So in this case, we are able to observe much more specific details if you compare this with the individual telescopes. Thanks to interferometry, we can simulate a giant mirror to distinguish details up to 16 times fainter than a single telescope. So in this case, why don't we make small telescopes and combine them to create a huge telescope? Well, interferometry also has limits, and some information is lost during its travel. However, it is still an excellent solution to observe objects too difficult to observe with our current technology. Okay, so right now we will come back to the tour screen. So now you will have the opportunity to visit a telescope, specifically the UT3 Malipal. We can't enter to all the telescopes, but don't worry about that because the four ones are identical in size and shape. So the only difference are the instruments inside. You can learn more about the instruments on the ESO website. Okay, so now we are going to enter UT3. And here we are. Okay, so what can you see? Well, this is a giant telescope. It's It's an impressive facility. Well, we are on the last floor of the telescope at the same height of the main mirror in front of us. The mirror has 22 tons with 8.2 meters of diameter and only 17 centimeters thick, created from a ceramic and flexible material called cerudur. So I am going to do a close-up here to show you the mirror. And something interesting about the mirror is that the surface of the mirror is a very thin layer of aluminium. So this very thin layer, about 80 nanometers of thickness, is basically the reflective material and is able to reflect light. Okay, and but the cell of the mirror, the main material of the entire mirror, is a ceramic and flexible material that is called cerudur. So, how can we point this telescope to the sky and move the telescope to different positions without breaking it? Because as you can see, it's a very, very big structure, and we have to move the telescope in order to observe different portions, sections of the sky. So you see that we have a dome here, and we have to open the dome to observe the sky. So I am going to show you the telescope from another angle to explain a little bit. I am going to show you the telescope from the telescope platform. So I will jump to another picture, and here we are. We are in the main uh, platform of the telescope. Okay, so as you can see, the mirror is mounted over this wide structure. Can you see? This is a cell supporting all the systems assisting the mirror, including something that we call active optics. And here you can see something like little gray boxes. I mean, this one, this one, this one. You see, this kind of boxes. Okay, they are called actuators. They are a kind of piston, and we have 150 in total. And we control this with a computer. They are acting on the mirror during the observations in order to keep the optimal shape of the mirror. In this case, the primary mirror um, has a concave shape, and we have to preserve this concave shape all the time because, well, otherwise it could suffer deformations just because of gravity, physics. So those deformations, even imperceptible in a first view, could be critical in the result of the observations. So that's why we have the actuators. Okay, so how is this working together? I will come back to the previous screen. I mean the picture from this level to explain. Okay, so in order to understand better what happens with the telescope when the telescope is observing, I want to show you a short animation, and we are going to explain that. The first step is to open the dome at night. You see? Well, of course, in this animation is exaggerated, but we have to open the dome, and then the light will impact first in the primary mirror, the 8.2 meter. Now, this mirror will reflect, will concentrate and reflect the light to a secondary mirror in the top. The secondary mirror is convex, and the light will be reflected again to a tertiary mirror in the middle, and from there the light will be reflected to, for example, the instrument in the left at the left side, like this blue square, or the red square representing the other instrument, or we can lift the tertiary mirror to reflect the light to another instrument that is located in the base of the system, in the bottom. So in this case, this is basically how the telescope is catching light. Now, in this picture in your screen, well, of course, it's possible to see the primary mirror here. The secondary mirror is this one. This is the convex mirror. But the tertiary mirror is a little bit complicated to see it from here because well, it's basically located there in the middle of the center, but it's difficult to see because we have this structure here. But basically, the tertiary mirror is there in the center of the system. So the tertiary mirror is flat. Okay, so only the primary mirror concave and the secondary mirror convex, they have some kind of a curvature, but the tertiary mirror is flat. Okay, so after all this process, as I told you already, the instruments will begin to receive the light, and the instruments will convert this physical light into a digital signal. And this signal will be transferred to another facility, will be transferred basically to a control building because the astronomers are located in another place, and they will take a look at the pictures from a computer. They are not here at night. Nobody is here at night because at night the telescope is completely in darkness, of course, to avoid the light pollution. But during the day, we have some engineers. For example, you can see some people there. The people working there are engineers because they need to prepare the telescope for the next observation night. They also can do some maintenance. They can fix some problems. So basically, um, they are doing all the necessary steps to provide a good well observation in the next night. And this thing here is one of the instruments. So you can see it's a huge thing. And something similar to this thing is located in the other side there, and other instrument will be located in the bottom. So this is basically what happens, and I mean with the light, when the light is reflected to one of the instruments, I mean to one of the mirrors, and when finally this light is going to the instrument, the light is converted into a digital signal. So the astronomers can take a look at the picture from the control building. Okay, so this is the explanation about this. In order to understand better what happens here at night. So now I am going to return to the VLT platform because from here we are going to visit the next destination, and this is the control building. This is the control building. As you can see, this place is located in the mountain top, but it's not at the same level of the telescopes. It's like in another um, in another location of the mountain top. I can show you this control building the from other perspective from here. So you can see that this is a big building, of course, and in the last floor of this building we have the control building. Sorry, the control room. So from this place we have the astronomers doing the observations. Okay, but before going there, because as I told you before, we have some time to answer some questions. I don't know, Felipe, if we have some questions so far.
That's
Felipe?
right. We have a first question for Lagdar from Algeria. Lagdar asks, my first question about this large telescope, that does it use to Schmidt-Cassegrain technique, and can the eyepiece be used for direct observation as in conventional telescope? Is a Schmidt-Cassegrain these particular telescopes?
Actually, it's something similar to an Schmidt Cassegrain. It's not like that exactly because, well, this is a very common optical system in amateur telescopes. But the optical system here is a little bit different. We can say that we are using a kind of similar system because we have a primary mirror with a hole in the middle. We have a secondary mirror in the top, it's convex, and we have a, another mirror in the middle to reflect the light again. Um, but it's a different uh, optical system. It's a little bit more complex than that.
Yeah,
But hmm?
sorry, this
Yes.
called the Paranal. The building system is called alt azimuth system technique. It's a mix of Cassegrain with the Nashmith system.
Yeah, exactly. Yes. Yeah. So the NASMIT focuses is basically when I show you before uh, this instrument here is in one of the NASMIT, right? Is in the other one, and they can use those locations to put the instrument and to receive light. Yeah. Um, and regarding the second question from this person, no, you cannot put an eyepiece there because this is not a conventional telescope. So
Mm.
basically, the only thing you can put there is the instrument, and the picture is a digital picture. So you are never looking at an eyepiece to observe with this telescope. This is something that happened in the past, but not in modern telescopes. So basically, in any modern telescopes, um, you are using an instrument converting the physical light into a digital system, a digital signal. Sorry.
And the last question have as a conventional telescope. No, you are sure, but this is only the only question you have. Remember, you can leave your question, comments, reading whenever you want to leave in your chat box about astronomy, about the telescope, about the virtual tour. So continue the virtual tour, Farid. And Lagarde, nice question you have. It's a common question for everyone you see in Paranal. Paranal is a big monster of the astronomy today in the modern days. And remember, if you want to visit this place in person, you can see the Paranal direct. You can see direct the telescope. Search for ESO.org to reserve the 1 day in a week for visit these observatories in Chile. So come on, Farin, let's
Okay.
continue.
Thank you very much, Felipe. Yeah, we are going to continue now. And as I told you already, we are going to visit the control room. This place is located here, and we are going to enter here. Okay, so this place, as you can see, is something like big office. Okay, so you have a lot of workstations with several computers, with people working there, and basically we have one workstation per telescope. So in this case, we have this workstation that belongs to Melipal. So all operations with Melipal are from here. So in this case, you can see some people working with doing maybe some calibrations, doing some tests before the next observation night. So you have some computers there, and you have some people working specifically on that telescope. In the opposite workstation, we have Jepun. So only operations with Jepun are from here. So again, you can see some people working with some computers, to do some monitoring of, I don't know, weather conditions, the status of the instrument, etc. So they are working from here. And if we continue working through this virtual corridor, we will find the remaining workstations. This workstation, for example, is for UT1 and 2, so only operations with and 2 are from here. So again, this place is very conventional, nothing too extraordinary, but all the science happens here. So during the night, the astronomers, of course, are in a very comfortable place. Well, they have coffee and cookies and whatever, and they can spend all the night here doing the observations because they need to work all night from sunset to dawn. So in this other workstation, we have Kuyen. So again, the same thing. We have several computers for different purposes, and in this case, I am going to show you in more detail this workstation. We have some people. You see, we have some people working. Okay, just to summarize a little bit so far, the control room. The control room is basically the place, okay, uh, from where we can control all the telescopes, instruments, and all systems. Okay, so during the day, engineers, technicians, and scientists are working to prepare the telescopes for the next observation night. And each night we have a telescope operator and an astronomer per telescope. So, for example, in this picture here, we have a telescope operator. This person. This person, the telescope operator is the person in charge of the technical details and the movement of the telescope. So it's like the pilot of the machine. Okay, so we can do the remote control of the telescope from here, and the telescope operator will be in charge of that. And in the same workstation, we usually have an astronomer. And okay, let's say that this person is the astronomer, and that the ESO astronomer is in charge to direct the scientific observations, and this person will decide the next steps. So he's like the co-pilot. Now, the observations are performed by experts from ESO for scientists from all the planet. So this is what happens here. It's basically a very comfortable place, as I told you already, and the people is working here all night. So basically, this is not like the observatories in the past, where you can use an eyepiece and you can use your eyes to observe the sky. Okay, so after this explanation, I am going to come back to the VLT platform right here. So, okay, so far, now you have a lot more information about the observatory and the people working here. Now I want to invite you to know more about the main scientific milestones made from all ESO observatories. I mean, La Silla, Paranal, and Chacnantor. So basically, scientific staff from different countries are using the ESO telescopes to study objects near to our home, the solar system, but also others located in the more distant places in our universe. Okay, so now we are going to take a look at this list of the top 10 discoveries from the ESO sites so far. So please, Felipe, thank you.
That's right. Let's go.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam, or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, this was the top 10. I hope you enjoy it. But we have something else. We have an additional um, important milestone. So we have a short video for that. Please, Felipe, if you have it, it's about the first image of a black hole. Okay, so a team of astronomers a few years ago were able to capture the first image of a black hole. The Event Horizon Telescope, or EHT for its acronym, is an array of 8 ground-based telescopes distributed on the planet, working as an international collaboration, and they were able to achieve the first direct evidence of a supermassive black hole. So the picture will reveal the black hole in the center of Messier 87, a massive galaxy in the close galaxy cluster in the constellation of Virgo. So this object is located 55 million light years from Earth, and its mass is about 6,500 million times the mass of our Sun. So a very, very impressive discovery that took place a few years ago. Okay, so now we are going to continue, and from this virtual tour, we will have the opportunity to do something very, very special. We are going to observe the night sky from Paranal, and this is very interesting because um, in one of the regular visits to Paranal in person, you can do it only during the day, not at night. So this is the main advantage of this kind of virtual tours. So you can take a look at the Paranal Observatory at night. So as you can see, the sky in this picture is almost completely dark with the last traces of light from the twilight. The moon is below the horizon and the sky is full of stars. So we are going to begin this journey um, with a very popular constellation that is located just above the Antu telescope. So I will show you here this constellation, and this constellation is Orion. The Orion constellation in the mythology represents a hunter. So I am going to show you a close up of this constellation. So you can recognize Orion with those 3 stars that are somewhat aligned, representing Orion's belt. And inside of Orion, we can see something else. We can see another interesting object. This object right here is the Great Orion's Nebula. Okay, so this object is very interesting because well, it's very bright, so you can see it even with your naked eye in a dark location, from a dark location, and of course you can have a much better view with binoculars or even a small telescope. So this is one of the most popular objects in the Orion's constellation, and is visible from both hemispheres, northern and southern hemispheres. Okay, so we are going to change the position and we are going to move to another interesting object that is located very close to Orion. We are going to move there, and I am going to show you that this star here is the brightest star of the night sky. This star is called Sirius. This star belongs to the Canis Major constellation, and this constellation represents one of the hunting dogs of Orion. So basically, the constellation of, related to this star, okay, this constellation represents a dog. Okay, this is one of the hunting dogs of Orion. So basically, the constellation, this one, is connected in the mythology to this one. This is part of the mythology, and it, each constellation has a different story in the mythology, and of course, they are very, very interesting. Okay, now if we come back to Antu, I will show you something that is very interesting as well. It's located just next to the telescope and is visible here. What is this? This this group of stars, okay, is something that we call the Pleiades. This is an open star cluster located in the Taurus constellation. Again, you can see this cluster with your naked eye, and you can distinguish, you should be able to distinguish at least 7 stars. So in the mythology, we call them in some cultures the seven sisters, for example. So this is another interesting object visible in this picture. So this is one of the very well beautiful objects from the southern skies. So the majority of those objects are visually close to a specific area that is very populated with stars. So, for example, if you look carefully, you can see that this is like path of light with more concentration of objects, right? This is because we are looking here at one of the Milky Way arms, our galaxy. And our sun is only one among hundreds of millions of stars in the Milky Way. So during the winter in the southern hemisphere, we can see the center of the Milky Way, and this is another area full of stars, of course, between Scorpius and Sagittarius. So you can see all of this from this hemisphere, from the southern hemisphere. So, okay, this is what happens here. This is what happens in this section of the sky. But now we are going to move to another sector, and I will show you 2 bright spots. I will show you this. So let's do a close-up, and I will show you something. Okay, those spots right here are the Magellanic Clouds. Up there, we have the large Magellanic Cloud, and down there we have the small Magellanic Cloud. They are not actually clouds, of course. They are galaxies with an irregular shape, both visible to the naked eye in a clear night like this one. This name refers to the records from Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So during this time, the people were unaware about what a galaxy is. So that's why the first people who saw these galaxies in the records, they basically put in the records that they are clouds because they look like clouds. Okay, and another important area here is the smallest constellation of the sky. I am talking about the Southern Cross, this one. So in this picture, the Southern Cross is tilted, okay? But it's this one. This is the smallest constellation in the sky, and it's very easy to find this one in the dark in the night sky. It's only visible from this hemisphere, the southern hemisphere, and it's a very good guide to find the South Celestial Pole. So the South Celestial Pole is basically a projection of the Earth's South Pole. So during the night, the stars appear to revolve around this point. So how to find this point? We are going to do this because in the southern hemisphere, we don't have a bright star next to the South Celestial Pole. And this is a difference if we compare with the northern hemisphere, because in the northern hemisphere, they have Polaris. This is a very bright star, very close to the North Celestial Pole. But what happens here in the south? We can do something with the help of the Southern Cross. Basically, we have to extend, well, in our imagination, the longer stick of the Southern Cross. So basically, we have to extend this. This is like the longer stick of the cross, and we have to do it about 4 times and a half. So if we do that, here we have 1, 2, 3, 4.5, and more or less like here, approximately, we have the South Celestial Pole. So this area also, if we try to look at the horizon from this point, so more or less like here, basically we are looking at the south cardinal point. Okay, so it's a very interesting concept because we can use the stars to find the cardinal points. So this is something very, very useful if you are doing some kind of outdoor activity at night. Okay, this is the conclusion of our visit to Cerro Paranal at night. Okay, so I am going to show you in a back um, daytime uh, picture. And now we are going to finish this virtual experience with a quick visit to a very interesting place that is located in the base camp of Paranal. So for this, we are going to rotate this view because we have to go down and we have to visit the base camp of Paranal that is located at 2,400 meters above sea level. So we are going to change the view. And as you can see, we have the base camp. We have a lot of facilities here, like rooms for contractors, a warehouse, the mirror maintenance building, etc. We have a lot of interesting facilities. But here we have the place I want to show you. This is the residence. The residence is the home of the ESO staff when they are working in the desert. So in order to enter, to access this area, we have to use this kind of ramp. This facility is not exactly underground. It looks like, but it's not exactly underground. It's just taking advantage of the shape of the land. So in the opposite side, we have something like a normal wall with many windows. But this, from this perspective, we have to use this ramp to access this residence. And this kind of dome, well, is the roof of the residence. Okay, so we are going to enter now. And as you can see, it's a very beautiful place. So basically from here, the workers can enjoy a more humid air. They have swimming pool, green areas, and of course we have a comfortable place to stay, protected, of course, from the intense sunlight from the outside. So basically, this is the home of the ESO staff, people with a contract with ESO, and also visitor astronomers. So you can see we have some plants, some the swimming pool. There we have the restaurant, we have the lobby, we have the reception. So it looks like a hotel, but it's only for the staff, only for the people working here. Okay, so with this view of the residence, I think we are in condition to finish this virtual experience. But before that, we have some time to answer the last questions. Felipe? Uh, okay, I cannot hear you, Felipe, but
Sorry.
okay.
Lagdar have a last question for him.
Uh-huh.
This I understand it. These telescopes are used to discover and study exoplanets. So why not use them to discover the supposed ninth planet, the ninth planet?
Okay, yeah.
Um,
In order to answer this question, and try to answer this shortly. You need to understand that in order to study exoplanets, to discover exoplanets, you are using some specific methods where your target is very, very, very faint. So you cannot see the actual planet, with the exception of some very specific cases of direct image discoveries. Okay, but usually you are observing to the star and you are doing some kind of study in the star in order to identify if maybe there is a planet orbiting this star, because maybe the planet is crossing in front of the star, I mean, transiting the star, or maybe is I don't know, doing some kind of perturbation in the in some kind of motion of the star. So basically, in order to discover exoplanets, you are doing some kind of indirect methods most of the time. But to discover something in the solar system, for example, this hypothetical ninth planet, in the same way, when you are trying to discover an asteroid, you need to observe a portion of the sky for several nights. And again, of course, we are talking about very, very faint objects. So you need a very powerful telescope, and you need to observe to a place of the sky that is very small. So of course, there is a component of lucky. You have and you have to be able to discover something that is moving. So basically, you need a lot of time to do that, because you need to take several expositions, several pictures of a very narrow, very small area in the sky. And after that, you need to identify if something is looks like it's moving. And even that, you need to do some additional observations. But and yeah, so eventually you can do it. But in a big telescope like Paranal, the telescope time is something very, very um, well, let's say, demanded. You have a lot of people wanting to observe in Paranal, so it's not easy to request telescope time to do a lot of observations like this, to discover something that we have no idea where is it. So, but fortunately, we have other observatories, other places that, yeah, they are basically dedicated to observe and try to find asteroids, and possibly in some cases to find something like an hypothetical ninth planet.
Uh, about that, don't forget the next week we have a La Silla Observatory. One week is La Silla, one week is Paranal Virtual Tour, and we have in English and in Spanish tour virtual tour. So you can see every Saturday at 11 a.m. So you can find and leave your other question because we have just in time to finish this virtual. And thank you for all questions you send, for our readings, our comments you send to us. And come on, Farid.
Yeah, sure. We are going to finish this virtual experience. We remind you that all these visits, information, and pictures are available on the ESO website, and we have tours every weekend. Sometimes Paraná, sometimes La Silla, sometimes in Spanish, and sometimes in English. Okay, so please stay in touch with the ESO social networks. And from my side, I just want to say thank you very much for joining us in this virtual tour, and thank you very much, and see you next time. So goodbye.
Goodbye, everyone.